Next mechanism to discuss is a particle hardening mechanism. Particles can be added in different ways. They can be added in the beginning of the process of manufacturing the material by just addition into the melt, but they can also be added in the shape of precipitates, that is through heat treatments of the material. That is illustrated in this picture. If you add an alloy element, the yellow circles here, into the base metal structure, it can look like this. We have the same effect as the solution hardening. We have a solution of the alloy element. In certain systems we can heat treat the material so that these alloy elements tend to cluster and then further on form a compound with the base material. And that compound will actually form particles, and those particles will be a very efficient hinder for the slip or dislocations. Now it's very important that the distances between these particles are small. To get a really strong effect, we should have a short distance between the particles. As it is a limited amount of volume fraction of the material that can be precipitated in the system, it must be so that every particle needs to be rather small. That's the trick when you want to do these heat treatments. It's very important to avoid that the particles grow too large. This technique to form precipitation hardening is very important in aluminium alloys, and especially in aluminium copper alloys and aluminium magnesium silicon alloys, which are the typical systems for heat treatment and precipitation hardening. Hardenable aluminium alloys are defined as alloys that can be a subject for precipitation hardening.